Introduction. Imagine a system that could automatically design the best neural network model for your specific needs, freeing you from the constraints of manual design and tuning. This is the promise that Neural Architecture Search (NAS) offers. In this first part of a multi-part series, we will delve into the world of NAS, its benefits and applications, along with some fascinating statistics and facts. By the end, you'll have a comprehensive understanding of the basics of neural architecture search and its potential impact on your business and the AI industry at large. What is neural architecture search? NAS. At its core, neural architecture search, NAS, is a technology that leverages machine learning to automate the design of neural network models. Traditionally, the architecture of a neural network or the arrangement of layers, neurons, and their connectivity is manually designed by human experts. This is a time-consuming and complex task that requires extensive knowledge of machine learning algorithms and principles. With NAS, the design process is automated. The system searches through the space of possible architectures, evaluating each one based on performance metrics such as accuracy and computational efficiency, to find the optimal design. This ability to automate model design makes NAS especially valuable in the fast-paced, data-dense world of AI. Benefits of neural architecture search. The benefits of NAS are manifold. First and foremost, it reduces the time and complexity involved in designing high-performing neural networks. According to a study by Google, NAS can design models that outperform those designed by human experts in just 48 hours. Secondly, NAS can uncover innovative architectures that humans may not think of. This leads to more unique and efficient models, capable of tackling complex tasks more effectively. A case in point is the discovery of the MNAS-Net model by Google's AutoML team, which demonstrated a 74.9% accuracy on the ImageNet dataset, surpassing traditional models. Lastly, NAS democratizes access to high-quality neural network design. It allows businesses and developers without extensive machine learning expertise to leverage and create cutting-edge models. This widens the playing field in the AI industry, encouraging more innovation and competition. Applications of neural architecture search. Neural architecture search is being used across various industries to enhance model design and performance. For instance, in healthcare, NAS-designed models are being employed to more accurately detect diseases from medical images. In the automotive industry, NAS is being used to improve the perception systems of self-driving cars. NAS also has applications in natural language processing tasks such as translation and sentiment analysis. For example, Facebook AI has leveraged NAS to create a state-of-the-art translation model that outperforms traditional models with less computational resources. In the next part of this series, we will delve deeper into the challenges and limitations of neural architecture search, provide interesting facts and data, and answer some common questions about NAS. Until then, ponder on the potential of NAS in your industry and how it could help you achieve better, faster, and more innovative AI solutions. Let's pick up right where we left off. Now that you have a solid understanding of what neural architecture search (NAS) is, plus its impressive benefits and a glimpse into its practical applications. As we continue, it's important to take a balanced look not just at the promise of NAS, but also at the real-world hurdles it faces. We'll break down some of the core challenges, dive into eye-opening industry statistics, and set the stage for our next deep dive. Challenges and limitations of neural architecture search. As revolutionary as NAS is, it doesn't come without strings attached. In our previous discussion, we saw how NAS can automate and even outperform human-designed models. But flipping the coin, there are several obstacles that make widespread adoption a bit trickier than it might first appear. 1. High computational cost. One of the earliest and most persistent challenges for NAS has been its resource demands. Automating the search for the best architecture means evaluating potentially thousands, or even millions, of candidate models. Each candidate requires training and validation, an enormously expensive process in terms of computation. For example, the initial NAS research by Google in 2017 required as much computation as training several thousand models from scratch. Not every company has access to dozens of powerful GPUs or TPUs for days on end. 2. Search space complexity. The space of possible neural network architectures is vast. Deciding how many layers to use, which kinds, convolutional, recurrent, etc., layer sizes, and how they connect can feel like searching for a needle in a haystack. While NAS algorithms are designed to navigate this space efficiently, there is always a risk of getting stuck in local optima, finding an architecture that is good, but not the best possible. 3. Reproducibility and transferability. Another concern is reproducibility. NAS results can sometimes be difficult to replicate, especially if search conditions or data preprocessing differ even slightly. Additionally, architectures found to work wonders on one dataset may not necessarily transfer well to another domain or task, limiting the immediate reuse of discovered structures. 4. Accessibility and expertise. While NAS is designed to democratize AI, running state-of-the-art NAS experiments still typically requires a fair amount of machine learning know-how and access to computational resources. That said, as the field matures, more streamlined tools and cloud-based solutions are beginning to emerge, but barriers remain for smaller organizations. Statistics. NAS in numbers. To put the impact and growth of neural architecture search into perspective, let's look at some telling statistics and real-world examples. Explosive growth in research. According to a 2023 survey of AI publications, research papers mentioning a neural architecture search grew by over 500% between 2018 and 2022. This spike highlights NAS as one of the hottest frontiers in AI research. Cost and performance gains. When Google first introduced NAS, the process took about 28 days and cost an estimated $10,000 in cloud computation fees. By 2021, improvements in NAS algorithms reduced the search time to under 48 hours and decreased costs by more than 80%. Real-world applications. Google's AutoML NAS-generated models achieved 82.7% top-1 accuracy on CIFAR-10, surpassing most manually designed architectures of the time. In the healthcare sector, a NAS-designed model enhanced the detection of diabetic retinopathy from retinal images, achieving a 15% reduction in false negatives compared to previous models. According to a 2022 McKinsey report, organizations implementing NAS in their AI pipelines reported a 27% average improvement in model performance and a 35% reduction in time to market for new AI features. Industry adoption. As of 2023, over 30% of Fortune 500 companies exploring deep learning have incorporated some form of automated model selection or NAS into their workflow, reflecting growing mainstream acceptance. Real-world example. AutoML and NAS in action. Let's revisit the example of Google's AutoML project. AutoML leverages NAS to automatically discover high-performing architectures for image classification and translation tasks. In fact, one NAS-designed model cut inference costs by 40% on Google's own platforms, all while maintaining or improving accuracy benchmarks. This not only saves time for machine learning engineers, but also brings down operational expenses. A win-win. These numbers and stories reinforce what we discussed in Part 1. NAS is not just theoretical, it is rapidly transforming how industry leaders approach complex AI challenges. In the next section, we'll shift gears to the lighter side of NAS. We'll share some fun and surprising facts about NAS, explore its history, and highlight a few pioneers who helped bring this technology to life. Stay tuned for Part 3, where we'll continue to unravel the fascinating world of neural architecture search. Transition from Part 2. Let's continue our voyage into the intriguing realm of neural architecture search. NAS. Thus far, we've examined the basics, benefits, and applications of NAS, as well as several challenges and illuminating industry statistics. Now, it's time to delve into some refreshing fun facts, and throw a spotlight on one of the influential figures in the NAS landscape. Fun Facts section. The birthplace of NAS. Neural architecture search was born in Google's laboratories. Their first NAS used reinforcement learning and took 28 days to discover a convolutional neural network architecture that surpassed human-designed models. Beyond images. While NAS is often associated with image classification tasks, it's also revolutionizing fields like natural language processing and voice recognition. NAS-generated models have achieved state-of-the-art performance in tasks like language translation and sentiment analysis. Speed matters. The advent of efficient neural architecture search. ENIS, a faster variant of NAS, can search for the best architecture within a few hours, a significant leap from the initial 28 days. NAS in space. NASA. Yes, the U.S. Space Agency is exploring the use of NAS for analyzing space data and improving celestial object detection. The power of transfer learning. Some NAS systems leverage transfer learning, allowing them to apply knowledge gained from one task to solve another. This significantly reduces the search time and computational expenses. Evolution-inspired NAS. Some NAS methods, like AmoebaNet, use evolutionary algorithms to search for the best neural network architecture. These systems evolve architectures over time, mimicking the process of natural selection. Not just for big tech. While NAS was initially reserved for tech giants with heavy computational resources, the development of lightweight NAS methods and cloud-based solutions makes it accessible to smaller organizations and individual developers. NAS and the environment. NAS could potentially contribute to more sustainable AI. By finding more efficient models, NAS can reduce the energy consumption of training and deploying AI systems. NASA's global reach. NAS research is a global endeavor, with significant contributions from institutions across the US, Europe, and Asia, reflecting the worldwide interest in this technology. NAS and the human brain. Some research groups are using NAS to design neural networks that mimic the human brain's architecture, opening fascinating possibilities for understanding our own neural structures. Author Spotlight. Kwok Le in the world of NAS. Kwok Le, a research scientist at Google Brain, is a name to reckon with. Kwok Le is one of the pioneers in the field of NAS, involved in Google's first NAS project and co-authoring the seminal paper, Neural Architecture Search with Reinforcement Learning. Lee's contributions to NAS have been instrumental in pushing the boundaries of automated machine learning. His work on NAS has paved the way for more efficient, high-performing, and innovative neural network models. Moreover, he has been a driving force behind making NAS more accessible and practical for real-world applications. From his early work on NAS to his ongoing contributions to Google Brain, Lee's work exemplifies the transformative potential of NAS in the artificial intelligence landscape. His efforts continue to inspire researchers worldwide, making him a key figure in the evolving story of neural architecture search. With these fun facts and the spotlight on Kwok Le, we hope to have added more color to your understanding of neural architecture search. As we move forward to the next part of this series, we'll answer some frequently asked questions about NAS. So, stay tuned to know more about this groundbreaking technology, its future prospects, and how it's reshaping the landscape of artificial intelligence. Part 4, FAQ section. 10 questions and answers about neural architecture search. What is the primary purpose of neural architecture search? NAS. NAS's main purpose is to automate the design of neural network architectures, a task that has traditionally been manual, time-consuming, and demanding high machine learning expertise. What is the search space in NAS? The search space in NAS refers to the set of all possible architectures that the NAS system can explore. This includes various combinations of layers, neurons, and connections. How does NAS evaluate different architectures? NAS evaluates different architectures based on performance metrics such as accuracy, computational efficiency, and sometimes specific criteria like energy consumption. Is NAS only useful for image recognition tasks? While NAS has been widely used for image recognition tasks, it's not limited to that. It has shown promising results in other areas like natural language processing, voice recognition, and even analyzing space data. What is efficient neural architecture search? ENIS. ENIS is a faster variant of NAS that can search for the best architecture within a few hours, making the process significantly quicker and more efficient. Are NAS-designed architectures always superior to human-designed ones? Not always. While NAS can design highly efficient architectures that can outperform human-designed ones, the results can vary depending on the task, the search space, and other factors. What resources are required to use NAS? Using NAS traditionally requires high computational resources and machine learning expertise. However, the development of lightweight NAS methods and cloud-based solutions is making it more accessible. Can NAS contribute to more environmentally friendly AI? Yes. By finding more efficient models, NAS can reduce the energy consumption and carbon footprint associated with training and deploying AI systems. What are some real-world applications of NAS? NAS has been used in a variety of applications, from improving the perception systems of self-driving cars and detecting diseases from medical images, to enhancing language translation and sentiment analysis models. What's the future of NAS? The future of NAS looks promising with continual advancements in technology and wider adoption across industries. It's expected to play a crucial role in making AI more efficient, effective, and accessible. NKJV Bible verse. As we explore the intricacies of NAS, a verse from the New King James Version Bible comes to mind. Proverbs chapter 18 verse 15, "The heart of the prudent acquires knowledge, and the ear of the wise seeks knowledge." This encapsulates our ongoing quest for understanding and improving the mechanisms of artificial intelligence. And NAS is a testament to that pursuit. Outreach mention. For additional insights into the world of NAS, check out Kwok Lee's Google Scholar profile. His numerous publications provide a deep dive into the pioneering work he and his colleagues have done in NAS. Strong conclusion. In this series, we have journeyed through the fascinating realm of neural architecture search. We've explored its origins, benefits, and applications, delved into its challenges, and shed light on its integral role in revolutionizing AI. As we wind up, remember that NAS holds powerful potential to automate and optimize neural network design, making AI more efficient, effective, and accessible. As AI enthusiasts, let's continue to seek knowledge and explore this promising domain. The future of NAS is bright, and it's here to transform the way we understand and apply AI. Looking for quality AI education? Check out the comprehensive course at best-icourse.com.